Data management. 1. Data management functions. Programs always handle data. However, devices and data I/O formats, which are used for handling data, vary according to the situation at the time. Because of this, it used to be that detailed I/O procedures needed to be programmed for each individual device. These had to be programmed according to the physical characteristics of each device, file organization and access method. However, to specify these one by one in a program takes a great amount of work. Creating them as general-purpose programs beforehand makes programming a lot easier. As a matter of fact, the complicated I/O processes, including file organizations and access methods, are managed as part of the data management functions of the OS, and as a result, the program is relieved of the burden of file management. In addition, when a device is replaced with a new one, it is necessary to change a particular part of the program which is dependent on the device. For example, if you change your disk from type A to type B, you have to find all portions directly associated with type A in your program, and change them so as to work with type B. It will be a lot of work. However, as a matter of fact, the data management function in the OS can be used to relieve the user programs of the burden of I/O control, in order to minimize or reduce impact on them. Two, Data I/O. As already explained, there is a data management function that performs the I/O operations in accordance with a request from the processing program. Let us use an illustration to explain the data output to a magnetic disk in the case of one block of 4 records. 1. The write instruction in the program is issued. 2. Data management stores the output record in the buffer as record 1. 3. The next write instruction program is given by the program. 4. Data management stores record 2 as a record after record 1 in the buffer. 5 and 6. The procedures in 3 and 4 are repeated. 7. When the buffer is full of records, it decides where and to which device the data should be written to and a SVC interrupt is generated. 8. The supervisor gives out an output instruction to the I/O channel. 9. The I/O channel begins the data transfer of the data in the buffer to the specified device and location. The steps 1, though 8, described above are repeated for the next write instruction. When data management transmits multiple records to the output device in this way, it stores one record at a time in the buffer. When the buffer is full, the entire records are sent to the output device. This is called blocking. In the case of input, the blocks transferred to the buffer from the input device are divided into records. They are then given to a running program on a per-record basis. This division of blocks is called deblocking. If more number of buffers is provided in data management, it is possible to increase the efficiency of input-output operations. 3. Volume label processing. In addition to the data records stored on magnetic disks or magnetic tapes, information called volume labels are attached at the head of volumes, and before and after data sets. These labels are used to identify volumes and files as well as for protection. When using magnetic disks or magnetic tape, the data management function first checks the volume label to make sure it is the correct volume.